Welcome to the Engineering Influence podcast from the American Council of Engineering Companies. And today we're going to be delving into a topic that is of great interest to our member firms who are designing in the built environment, especially increasingly for both private and public clients. And that is the issue of embedded carbon, dealing with sustainability, embodied carbon, and really just a question of how is the industry addressing carbon reduction in the built environment. And to really focus in on this, we're very pleased to be joined by Kelly Roberts. She is the Principal and Managing Director of the Atlanta Structures Group for Walter P. Moore, and she is also the leader of the firm's Sustainable Design Practice Group. Kelly, thank you for joining us.
Thanks so much for having me.
Now, I really want to focus in on this report that was put out by Walter P. Moore on embodied carbon insights for industry impact, which is available on the Walter P. Moore website. That really is a very good dive into the subject and includes case studies and examples of not just issues related to design, but also materials, concrete and low carbon concrete and mass timber and the like. But Kelly, for those who might not be completely familiar with the issue itself, can you define embodied carbon and how it's become a central focus for governments in dealing with approaches to environmental policy and carbon reduction?
Sure. So embodied carbon refers to the greenhouse gas emissions measured in carbon dioxide equivalents, or so CO2e, that result from the life cycle of building materials. So in our industry, it's the carbon emissions that are associated with the raw material extraction, transport, manufacture, construction, the entire process of all the materials that are used for the construction of buildings, roads, bridges, and really anything else. So it's probably important to note here at the beginning that I'm a structural engineer and I work in commercial, architecturally driven building design. So I do quite a bit more vertical work than horizontal. So I have a pretty buildings focused point of view. So I will say my point of view is largely the building industry. But the reason why it's become such a central issue for governments is really every year 66 billion square feet of buildings are constructed, and the embodied carbon emissions of that construction is approximately 3.8 billion metric tons of CO2 per year. So it's a huge amount of carbon. In fact, the building industry in general is responsible for 40% of the world's CO2 emissions, with operations associated with those buildings making up the majority of those emissions. And until the last 10 years or so, embodied carbon had not been getting as much attention as operational carbon because it wasn't as big of an impact, or so we thought. Operation was always driving a bigger piece of the pie. So up until about 10 years ago, this is where the focus was, driving down operational carbon. It also impacts people's pocketbooks. Operational carbon does, operational energy does. So this is where a lot of the focus was. But the critical issue regarding embodied carbon specifically is that it occurs before the building opens. It never gets reduced. No future efficiency will drive down embodied carbon. You can't add solar panels. We can't clean the grid and make up for the embodied carbon that we sunk into those buildings. So because embodied carbon happens up front, over the next 30 years, embodied carbon will actually account for half of new construction carbon, according to the IPCC. So as we approach 2050 and we try to decarbonize the building industry, we can't get there without focusing on this big piece of the pie. And for me, as a structural engineer, much of the embodied carbon in a building is contained in the materials I specify every day in concrete, steel, and wood products. Those are the high carbon materials that dominate the embodied carbon of a building. So driving down the impact of those materials, that's where my big focus lies in sustainable design.
It's a huge issue. It really is, because to your point, really it is a question that embodied carbon in buildings is there. It's not something that can be dealt with after the fact. Once the
Right.
building is constructed, there it is. And governments around the country and around the world are trying to deal with this. Urban planning, reuse of buildings, or compared to new construction. There seems to be a number of pathways, policy pathways, that governments seem to be addressing the issue. And your report kind of outlines a matrix of a systemic or materials approach. Can you kind of describe that matrix of policy pathways and how governments are choosing to address the issue of embodied carbon?
Yeah, sure. So, there are really four main pathways for policy, with both prescriptive and performance pathways for material and system level approaches. So you have prescriptive material and performance material approaches, and then prescriptive system and then performance system level approaches. That's basically the outline there. Material level prescriptive pathways generally focus on things like percent recycled content, as we saw in previous versions of LEED, or specific sourcing requirements for materials such as sustainably certified wood. Those are prescriptive material pathways. Um, but material level performance pathways, like a buy clean policy, typically require material specific reductions to high impact structural and architectural materials like concrete, steel, and aluminum. So you're focusing on things like structure and facade, but you're doing performance based material pathways. And then there's system level performance pathways that are focused on whole building lifecycle assessment, or what we call WBLCA. So those typically require a percent reduction from a baseline building. And if you're not familiar with whole building lifecycle assessment, it's an ISO governed process that quantifies the environmental impacts of an entire building, including at least the structure and enclosure over its entire life cycle from cradle to grave. So looking at all of the materials that are in the building and looking at those materials over their entire life cycle and looking at the building over its entire life cycle. So looking at different policy, so that would be included in a system level performance pathway. So, looking at different policy types, a lot of them use a combination of these policies to address reductions. Jurisdictions like California came up with Cal Green that use a lot of these different types of policies to address reductions.
Yeah, there doesn't seem to be, and to your report, it kind of calls this out, that there's not a one size fits all approach to this, that it's not a question of either or, but instead, in the reporter's view, a both and approach instead of either or is probably the best course to take on this. Can you explain that a little bit more as well?
Yeah, so we're definitely advocates that if you're going to enact any type of policy, that it consider at a minimum performance pathways, and we are big advocates for system level performance pathways, since those would typically be considered the most robust and comprehensive. So those are the all encompassing that look at everything for the whole building over its entire life cycle. There isn't a one size fits all, and buy clean policies, which are material performance pathways, are very useful for low carbon material procurement. And they send a clear message to manufacturers about moving the industry forward. So there are definitely places for both types of performance type pathways. So yeah, we are in the both and camp if policies are going to be enacted, but are wary of any policies that would that would be disincentivizing a whole building life cycle assessment, because we think it is the most robust.
Looking at the built environment as it stands, there's been a push, especially during COVID and after COVID, really the realization that there are so many buildings right now that are either empty or are facing a situation where the workforce of yesterday is not required, hasn't had the same requirements of the workforce today. Walter P. Moore, you've gone hybrid. We also went hybrid, and actually at the beginning of the pandemic, we signed a lease at a new building to build out a new space. With a lot of this in mind, we hired a firm specifically. I think it's the same firm that worked on your Washington D.C. headquarters, actually, to figure out how this space should be oriented to a hybrid workspace, and to really look at the whole life cycle of the operation there. You notice a lot of buildings that are going under renovations, or they're being redeveloped to serve another use than the building was originally designed to have. For urban planners looking at the question of building new and incurring that new cost of potentially that carbon sink into new construction, or really just how do we take what's already here and do a renovation in such a way where we have a limited environmental impact. How does Walter P. Moore, how do you look at that? You talked about materials, and it seems as though engineers need to be, it's kind of the artisanal approach almost to engineering, is there. You have to not only look at the materials, but you have to look at exactly where those are sourced and how they are manufactured, because that also accounts for the carbon footprint of that building. How do you approach that question of new building versus redevelopment, and then how do the materials that you specify for that redevelopment?
Yeah, sure. You know, the greenest building is the one that's already constructed. And so I think that we've seen a lot of focus on repositionings and conversions. So I think that urban planners are definitely looking at those within the building stock. Um, and there's definitely been a push for that in recent years. So incorporating the carbon impacts of demo and renewal into the overall analysis of new development can help cities select optimal sites for redevelopment and retention. And we suggest that cities compare and assess the carbon impact of necessary upgrades to meet current codes compared to new construction. And then also considering the building envelope. So looking at the whole thing and looking at the buildings as a carbon sink that have already been uh, created, but specifically looking to hybrid work and how we're approaching it. Like many firms like yours, we've adopted a hybrid work model and are not in our office spaces every day. So we've been, looking at how we're using our workplaces differently and have been undergoing renovations in order to optimize those spaces for hybrid. So our carbon report actually highlighted what we did in our Washington, D.C. office. And on that renovation, we really wanted to understand our carbon impact. So we performed an interiors LCA. So historically, interior LCAs haven't really been done very much, and interior spaces have been overlooked in discussions about embodied carbon emissions because we're looking at the big ticket items like concrete and steel and wood and we're looking at these bigger ticket items. So it's as there's been less of a focus on doing interiors LCAs, but we wanted to do it on ours because we wanted to really understand all the materials that we're working with now that we were working with some interiors materials. Um, and it really informed us about the importance of starting the conversation early and using an embodied carbon as a performance metric throughout the entire design process. We saw in that LCA that one of the most impactful ways to reduce carbon is through material reuse and circularity. Um, on that project through furniture reuse alone, we achieved a 23% reduction in global warming potential than if we had purchased all new furniture. And I think that was eye opening about the importance of reuse around designing around the pieces that you already have, which is not as common in a redesign to really take stock and inventory of what you have and find new places for it in your redesign. Um, I think LCAs are becoming increasingly integral part of the design process in general, and hopefully the availability of impact data for interior components will increase so that we can see more interior LCAs done on projects.
It's a really important an interesting point you raised, because historically it's always been seen as, okay, we're going to get a new office space, so it's a new opportunity to have a clean page. So we're going to buy everything new, everything that we have we're going to replace, and we're going to build out exactly what we need. And it makes more sense to take stock of the existing assets that you have, and to your point, design around what you already have, so you're not looking at purchasing all new items,
Yeah,
because everything has an economic has an environmental footprint, down from printers to paper to chairs to everything else, to really save that by reuse. It's I guess it's not a very American way of looking at things, is it? We're so set on new next. Let's out with the old, in with the new.
that's
That
right.
we need to figure out a way where we can actually create that balance. So that's very interesting. I can't remember if we went to that detail on our redesign. We did look at the materials. We did look at how we were going to actually consume power. How were the HVAC systems going to be operating, all the way down to kind of the overall structure of the floor that we have. That is really, compared to the office that we had before, which was your typical kind of DC office, where it was everybody was in a closed off space with one or two main hallways going to an open space that has a lot less material. Definitely
Sure.
had a benefit. Um, I do want to go into the issue of materials, and there are two that you call out in the report. A good case study that you have is the Intuit Dome, which was newly constructed and took advantage of low carbon concrete. Had a podcast not too long ago of a member of the American Concrete Paving Association, who is on the kind of researching board on low carbon concrete. Kind of go into that as a material option. Where does it stand right now, and how was that used with the Intuit Dome to really reduce that structure's embodied carbon during construction?
Yeah, so the thing about concrete is that it's one of the world's most prevalent materials and the second most used substance on Earth after water. Unfortunately, it's also one of the most impactful materials to our environment. It accounts for up to 8% of the world's global CO2 emissions. But what's interesting about concrete is that although it's made of coarse and fine aggregates, water, admixtures, and cement, it's the Portland cement component of concrete that accounts for its large carbon footprint. In fact, up to 96% of the CO2 emissions in a concrete mix are attributable to the cement content. And that's due to both the incredible heat required to make the clinker and also as part of the natural chemical reaction of the process. So whenever you're looking at trying to reduce the carbon footprint of a building, you have to consider concrete and optimizing the cement content of the mixtures, and then looking at any cement replacement. So the example that we put in our report was Intuit Dome, as you mentioned, and Intuit Dome is the new home of the LA Clippers and is located just across the street from SoFi Stadium, which is another one of our projects. The owners of Intuit wanted this project to be climate positive. Um, but back in mid 2021, when we were designing this, the prevailing strategies in SoCal for generating low carbon mix designs um, really relied on supplementary cementitious materials like fly ash, we call them SEMs, to replace the cement content. But then there was a critical Caltrans standard specification that allowed the use of Portland limestone cement, or PLC, or Type 1L. All of those things are the same thing. Type 1L cement is a blended cement that's covered by ASTM C595, and Type 1L cement typically has 5 to 15% of its makeup comprised of limestone instead of clinker. This results in Type 1L cement having a lower carbon emission than typical Portland cement, since up to 15% of it has been replaced by natural and unprocessed materials, unlike clinker. Um, so going back to the project story of Intuit Dome, that Caltrain Caltrans spec change not only provided an opportunity for us to explore optimizing our SCMs, but also open up additional avenues to assess the optimal cement choices. Um, so during that mix creation, only one of the six cement plants in California was producing Type 1L cement. Um, but the really the entire team decided that that's the way that we should go. And following a lot of successful implementations and things like the foundations, the decision was made on the project to predominantly use Type 1L cement. So that transition plus the use of Orca aggregate, which is an aggregate that's trucked down from the Pacific Northwest to California, that all resulted in I think 25% average reduction in the embodied carbon of the concrete placed at Intuit Dome. So I think overall that is a significant reduction for the overall concrete, and that's based on a comparison to a baseline for the regional, I think the regional NRMCA benchmarks.
How beneficial was it to have a client that was also dedicated to making the stadium climate positive, in allowing you to have the flexibility to test and evaluate different forms of concrete to get a 25% reduction? It seems as though you need to have an active partner on the client side to be able to say, yes, I am invested in this and I do want to have, my structure come out to be climate positive or as close to climate positive as possible, to give you the flexibility and freedom to explore those things. How important was that in that project?
Yeah, that's critical on that project and every project where we're trying to do something, where we're trying to move the needle, right? Having a client that is on board, that's interested, that's willing to try new things, to take some risks, to allow any time in the schedule, to try new things. That's everything. It's very difficult for us to push strategies up as structural engineers. We can be sometimes lower on the totem pole, of all the people in a project. So it's pretty difficult for us to do things on our own. We do try all the time to be doing things on our own, even if a client is not specifically requesting it. But we can absolutely make bigger gains and move the needle more when we have an owner client who is willing to go the mile with us, that is willing to go down the rabbit holes, that's willing to explore the strategies. That is extremely important. It's one of the reasons why we put out things like our carbon report, so that we can get the story out there to more people, to kind of spread the love, spread the ideas, spread our thoughts out into the universe.
Yeah, absolutely. And another material that you mentioned in the report is one that I personally really like, and that's mass timber, which I think we're seeing a resurgence of, hopefully, which is a great material because it's naturally is naturally a carbon sink. You have it's ease of construction. You as a material, it speeds up construction. It's beautifully aesthetic. I mean, it's just amazing what you can do with mass timber now. Um, where do you see that fitting in? Do you think that the mass timber market's going to be something that's going to be growing, given the fact that it has so many positives for sustainability?
Absolutely. I mean, I think the mass timber market has been growing exponentially in the United States as we see more and more projects consider using mass timber as the structural system. People love the feel and look of natural wood, so I think we're just drawn to it as humans. We've seen several mass timber buildings pop up around Atlanta, where I live, and I'm actually working on a mass timber and steel hybrid project over in Alabama. Our carbon report actually featured the Anderson Ball classroom building at San Jacinto College in Texas. And when it opened in 2021, that three-story building became the largest instructional building in the U.S. made from mass timber, at about 120,000 square feet. So very large mass timber instructional building. Um, and I think it's been extremely successful. By all accounts, the university is extremely pleased, and the students are pleased. It's a space that people really, really enjoy. And what's great about that story is not only did using mass timber align with the college's sustainability goals, but it also accelerated the overall project schedule due to the prefabricated nature of mass timber. So it was really a win-win. And I love project stories that can be a win-win on all sides. I think that's when you get into, true sustainability.
And really, with modern design practices, really the limits on mass timber, as a building material really have been lifted. There are story structures, and like you said, a 3-story large classroom building, that can be done in mass timber now. It really is limitless on what you can do with it, especially if you combine it with steel, structural steel, and other materials to complement.
Oh yeah, absolutely. I mean, I think that we've seen a lot of development in codes, in specifically the IBC, that allow more use of mass timber. There's all the categories now for Type 4, and then Type 4A, B, and C. So there's a lot more flexibility in using mass timber now, and I think that's allowing designers to kind of push the limits and see what's possible, in multiple market types.
Yeah, absolutely. Well, Kelly, the report's great. I really encourage anyone out there to go to the Walter P. Moore website to download the report. We'll put a link in the description on the show notes. And not only this report, but there's a wealth of thought leadership that Walter P. Moore has on its website, that is, of course, focused on sustainability and green building principles, but many other subjects. Is there anything we didn't cover that you want to make sure our audience knows before we wrap up?
I would just encourage everyone to, start small on your projects. Start just by understanding what's in your building, understanding or in your project. Start to understand your carbon. If you are brand new to this, there is a lot of information available on SE 2050's website. SE 2050 is the structural engineer's commitment, to reducing embodied carbon by 2050. And there is an embodied carbon calculator on that website. And there's just a ton of resources. So if you're brand new to this and you're just trying things out, go to that website, and you'll find a wealth of resources to get you started.
Fantastic. Again, Kelly Roberts with Walter P. Moore, thank you so much for joining us today on an exciting topic. Look forward to having you on again on this, especially as, who knows, we have a lot more happening in Washington. Maybe we'll have some more incentives on using a low carbon concrete or mass timber. I know we have a couple of members of Congress in the House that are advocates of mass timber, and hopefully we can have some movement on that. So we'll be happy to have you back on the show.
Yeah, would be happy to. Thanks.
Fantastic. And again, this has been the Engineering Influence Podcast from ACEC. We'll see you next time.